Hello again. In this module, we will be preparing the prerequisites for the city generator system that we will be creating. We will start applying what we have learned in the previous module here, building the first parts of the actual city generator system. The city generator requires a number of components, a number of inputs for it to create output. The city blocks are one such input. To populate the city blocks, we need buildings. These buildings would have been made by a modeler, most likely from the modeling department of your company if you work in the film or advertising industries. From these buildings, we then create building clusters, which is what we will actually use to drop onto each city block. Creating the system that will allow us to do all this, we will be applying a number of things we learned from the previous module and expanding on it. So let me explain this in a little bit more detail. We will be importing a city plan, basically a piece of geometry that looks like a city map. Roads and such have been cut out, leaving you only with the actual city blocks. This would be an item created by the layout department passed on to you to do your effects magic on. Since we are creating a city, we would have a lot of buildings to work with. Having done something like this before for a feature film, we had over 130 different buildings modeled by a team of modelers to the finest detail. The modeling department doesn't necessarily know exactly what it is you are doing and so really can't plan for it. It is up to you to add to what you receive from them to make your system work. Think of converting geometry to other types of geo, adding attributes, and other such things. Of course, we can't go and drop a file node for each building, find the file, and then append a number of nodes to create the attributes we need and so on. We will do this in an automated fashion by using a Python script to do this all for us. This also means that if buildings are added to your library or buildings along the development process are updated, all you have to do is hit the button and run your script. Most of these buildings will be tens of thousands, if not hundreds of thousands of tries. To keep our system light, we will convert each one into a bounding box so we are looking at 6 faces per building rather than 100,000. If we wouldn't do this step, we could not build the system we are building and have it run smoothly because of the overwhelming poly count that would be involved. Once we have our import script, our buildings imported into our scene, added the attributes to them we need them to have, and turn them into bounding boxes, in the following module, part 2, we will then go ahead and create clusters of the various buildings. The way we do this is a copy stamping technique. We take a grid of points, randomly scatter onto it our buildings, making sure we get some variety in there, and then we pull them together to form a tight bunch as you would find buildings huddled wall to wall in real cities. While trying to figure out how to scatter buildings neatly and tightly onto a city plan, I tried various techniques and found out that this was actually a clever way of getting what I want while avoiding intersecting buildings. This is because we first scatter them around well spaced out before then pulling them together in a bullet simulation. More on this as we get to it. Finally, what we do is grab one of those single city blocks from our city plan and grab one of the building clusters we created and overlay the cluster over the city block. We'll make sure the clusters are way bigger than the individual city blocks to ensure we always get a complete fill. City block shapes can differ greatly and some will be bigger than others. The way I decide on how big my clusters need to be is by looking at the city plan, finding the biggest blocks and then preparing my clusters so that they will comfortably overlap that block. That way we should get a good fill of buildings for each city block. Let's dive into Houdini and get started.